Hey, welcome back to another unit in Algebra 2. This is exponents and logarithms, exponentials and logarithms. We're going to start our first lesson today by doing some just simplifying of some exponent expressions. We'll do some evaluating, so a lot of review, but maybe a few new things to keep a lookout for. And here we go. In this lesson, we'll review the basic properties of exponents. So let's take a look at our exponent rules. If a is a positive real number, then these rules will all apply. That a to the m times a to the n is equal to a to the m plus n. If we're dividing a to the m divided by a to the n, then we subtract the exponents. Remember, the base is the a and the exponent is the m and the n. So the base has to be the same. If we raise a power expression to a higher power, we just multiply the exponents. So a to the m to the n becomes a to the mn. A to zero power is 1. Anything to the zero power is 1. We need to remember that. A to the negative m is 1 over a to the m. Very important way to realize that. It doesn't make it negative. It makes it a reciprocal. And here, this might be a new one for some of you. A to the m over n is a radical expression. So fractional exponents, rational exponents, are actually radicals, where the numerator is the power on a and the denominator is the root index. All right, let's take a look at some examples. We're going to simplify the following expressions. We're going to assume all the variables are positive. We don't have to worry about imaginary numbers creeping in or dividing by 0. So that'll make it just a little bit easier for us while we're doing these. Okay, so we start with this one here. We're going to multiply the coefficients 8 and 2. And I'm going to x to the fifth times x to the second. So I'll add the exponents. Y to the third times y to the second. Y to the fifth. All right, on the next one, I'll multiply x to the third times x to the second, get x to the fifth. Y to the negative fourth times y to the negative third is y to the negative seventh. But I can rewrite that as x to the fifth over y to the seventh. For now, I want you to write all of your expressions with positive exponents. So if you have a negative exponent, you need to move it to the denominator. In reality, in math, we oftentimes do like to have negative exponents, and other times we don't. So what's important going forward is that you're able to convert between the two so that you can, set up the problem the way that makes it the most easiest. But for now, we're just going to always make them positive. All right, now on this next one, there's lots of different ways you could do this. I could start subtracting right now, but I like to move bases and with negative powers before I divide. First, I will go ahead and reduce by dividing each of these numbers by 4, giving me 2/3. So now I have 2b to the fifth over 3a to the third, a to the second, b to the second. So I just took a moment to move any negative exponents from the top to the bottom. Or if I had negative exponents on the bottom, I'd move them to the top. So 2b to the fifth over 3a to the fifth. Oh, and the b to the second and b to the fifth. We need to subtract. So subtract 5 minus 2 is 3. And because 5 is bigger than 2, that's why the b cubed is on top. All right, this is a power to a power, so 3 to the third is 27. Then x squared to the third becomes x to the sixth. This becomes y to the ninth, and then z to the third. All right, so I'd like you to pause the video, please, and then try these 4 exponent problems. Simplify, and don't leave any negative exponents in your answer. All right, let's see what we got. 3 times a negative 2 is a negative 6. Then x to the ninth and y to the fifth. Please be careful. The negative 6, so you don't try and move that or anything like that. That's got an exponent of 1. It's just a negative number, not a negative exponent. On the next one, 3 times 5 is 15. I have a to the negative 9 and b to the first. And we will move the a down, so 15b over a to the seventh. Okay, on the next one, we'll reduce the 12 and 9. They're both divisible by 3. And then, like I said, I could go ahead and start subtracting, but I like to move all of my negative exponents first. I just find that easier. So the x to the negative 3 on top goes down. And there's another x to the 3 down there. There's a y to the negative 2 on bottom, so it needs to move up and come y to the positive 2, and then z. All right, so we have a 4 and a 3, and let's see here, y to the 7th, z to the 8th, x to the 6th. All right, let's take a look at the next one. Negative 2 to the 4th. It's a negative number inside an even power, so you can just immediately say that's going to become positive. 2 to the 4th is 16. Anything to the 0 power is 1, so 1 times anything is itself, so the x is going to go away. Y to the negative 4th, z to the 8th, and we'll just move the y's down now. All right. When a base has a rational exponent, the numerator is the power, and the denominator is the root. And the way I always remember that, or tell people to remember that, is that a base is like a tree. Okay? It gets its power from the sun up above, all the while its roots are down below. Okay, so just remember, roots down below, power up above. So we can rewrite the following rational exponent expressions using radicals. So the 1/2 power means x to the first to the second root. And we don't write the 1, and I don't put the 2 on this index here. X to the 2/3 means x squared cube rooted. Or, if you prefer, you can write it as the cube root of x squared. The order does not matter. I prefer to evaluate in the second order, but I prefer to write it in the first because I don't like to have parentheses if I don't have to. All right, now let's try going the other way. I've got a radical expression, and I want to write it with rational exponents. Since this is a times b all inside a radical, I need parentheses around it to the 1/4 power. This one here becomes x to the power is 5, and the root index is 2. So x to the 5/2. All right, let's practice evaluating some of the common exponent expressions. I've got 2 to the 3rd plus 3 to the 2nd. So to add them, I need to go ahead and evaluate. 2 to the 3rd is 8. 3 to the 2nd is 9. 8 plus 9 is 17. 9 to the 1/2 means the square root of 9, which is 3. 8 to the 2/3 means the cube root of 8 squared. And I recommend you do it in that order, because if you square the number, then you got to take the cube root of a bigger number. It's much easier to cube root it and then square it. So the cube root of 8 is 2, and 2 squared is 4. 4 to the negative 2 is 1 over 4 squared, which is 1 over 16. Negative 4 squared. Now, the negative in front of the 4 does not get the power, so it's just a negative and then 16. Because the negative's not in parentheses, the exponent goes just to the number. Now we have 16 to the negative 3 over 2. It's kind of hard to see, but this is a negative symbol. So that means it's 1 over 16 to the 3/2. Then I do the root first. Take the root. I don't want to cube 16. I don't even know what that is. Take the square root of 16 first because of the 2 on the bottom, which is 4. And then 4 cubed is 64. 7 to the 0 plus 3 to the 0 is 1 plus 1 equals 2. That was fun, right? All right, I do have a couple practice problems for you to have fun with. Practice 1.2 and then 1.3. And pause the video and give those a try, please. All right, let's see how you did it. 2 to the 4th is 16. 4 to the 2nd is also 16, so that is 0. 27 to the 2/3 power means we're going to take the cubed root of 27, and then we're going to square it. The cubed root of 27 is 3, and 3 squared is 9. All right, this is an 81 to the negative 1/2, so it's 1 over 81 to the 1/2. I know they don't show up that well. The square root, that's what that means. The root of 2. So square root of 81 is 9. So this is 1/9. 5 to the negative 2 is 1 over 5 to the second, or 1 over 25. Negative 3 to the 0 is just 1, because any number to the 0 power is 1. Do be aware that it's important that the negative was inside the parentheses. Had it been just this, that would actually equal negative 1. But that wasn't what the question asked. All right, this becomes 1 over negative 8 to the 1/3 power. The cube root of negative 8 is negative 2. So this is 1 over negative 2. Or you could write it with the negative on top or out in front. Doesn't matter, just as long as you have one negative somewhere. 64 to the 2/3 is the cube root of 64 squared. The cube root of 64 is 4. And 4 squared is 16. 7 to the 0 is 1. Negative 8 to the 2/3, the cube root of negative 8 is a negative 2. And negative 2 squared is 4. This is 1 over the square root of 36, so it's 1 over 6. All right, on practice 1.3, you were to rewrite the following expressions using rational exponents. So let's do that. The square root we know means 1/2 power, and I need parentheses around it. This becomes x to the 4/3, and this part becomes y to the 3/2, and that's all I can do. On this next one, I'm going to have the cube root of x squared times y to the 4th times the square root of z. On this one, though, since the two x and y cubed are all to the 1/2 power, I can put the entire part of that inside a square root function. Kind of an important difference between c and d there. Lastly, I ask you to rewrite the following expressions using negative exponents so that no variables are in the denominator. This is actually a little technique that we use a lot in calculus. We like to rewrite our expressions with no variables in the denominator because it makes some of the work easier. So this would be 2x to the negative 1. And the 3x squared is fine. And then I'll move this up as well, making this 5x to the negative 1/2. So you may feel like this is going against the simplifying we've been doing, but it's important to be able to go both ways. All right, let's try the next one. That would be 7x to the negative 1 minus 4y to the negative 2 plus x over 3. All right, practice 1.4. I want you to simplify each of these, and then we will go over them. All right, multiplying 2 and 5 together, you get 10. A to the 5th times a is a to the 6th. Then this becomes b squared, c squared. On this one here, you should have rewritten this as 2 squared a cubed over b to the 4th. And 2 squared we know is 4. (2x to the negative 1 over y cubed 3yz to the 0). So I will move stuff first. And z to the 0 is 1, so timesing by 1 doesn't change anything. And if I just do a little bit of simplifying, I'm going to move the coefficient in front just for style. And I get 2 over 3xy to the 4th. All right, on letter D, how do I handle this big negative exponent? Well, there's lots of things I could do. I could apply it to each one right off the bat. I could say 2 to the negative 2, a to the negative 6, b to the positive 4 over negative, well, a negative, this is still an even power, so that negative is going to become a positive. So this is a to the negative 4, b to the negative 10, and then I can move things around. Alternatively, it's totally okay when you see a negative exponent to just flip the fraction. And so I could just take everything on top and put it on bottom, everything on bottom, put it on top, and that gets rid of the negative. So that's another way to do it. I like doing it that way, but I find most of my students prefer to just apply the exponent and then move things. So let's see here. The b to the 4th is okay. The a needs to come up from the bottom. B needs to come up from the bottom. So I've done that one, that one, that one, and then 2 squared a to the 6th. And now we can go ahead and combine some things. I got b to the, what is that, 14 over a to the second, because I got 4 on top, 6 on bottom. So 6 minus 4 is 2, but there were more on bottom, so it goes on bottom. And 2 squared is 4. This is actually a pretty important little extra ticket. It says explain the difference between x to the y cubed and x to the y cubed. And the important difference is in the order of operations. And this is something a lot of people don't realize, that the order of operations works from inside out. So it is very important that I have the parentheses there. Because if I don't, this expression really means x to the y cubed, which is actually quite a different thing. And while this expression equals x to the 3y, this one does not. Let me explain what I mean by there. When I have x to the y cubed, that means I have x to the y times x to the y times x to the y. So we add the exponents and get x to the 3y. But on this expression, that doesn't mean that at all. It means I have x repeated some y cubed amount, and I don't know what that is. I have no idea what y cubed is. I couldn't possibly begin to simplify this, because it could be x lots of times. It depends. So, really different situation. Well, that's it for this lesson. I'll see you in the next one.